So picture your favorite website. You're probably imagining like the massive hero image, the sleek typography, maybe the brand colors or the smooth animations.
Right, the stuff you actually see.
Exactly. But if you strip away the paint, strip away the branding, what are you actually left with? You're left with the invisible architecture that truly runs the internet. We are talking about tables and forms. So welcome to this custom-tailored deep dive, where today's mission is to decode the hidden structural language of the interactive web based on an iTech 1030 web programming deck, specifically Chapter 6.
Yeah, and it's a really crucial shift in perspective for you as a listener. A website that just sits there looking pretty is essentially just a digital poster.
Yeah, exactly.
But the modern web is a living ecosystem.
Yeah.
So today we are exploring the overarching architecture of how we structure complex data so it can be parsed correctly, and how we build dynamic forms to actually collect that data back. Every analytics dashboard, every sign-up flow you interact with relies entirely on the tag families we're about to cover.
Okay, let's unpack this. Because I promise you, by the end of this deep dive, you will literally never look at a pricing grid or a simple login screen the same way again.
It's true. You really won't.
So we have to start with how we present data to the user before we can ask for data back. That means diving into tables. And the source material has this brilliant, incredibly simple heuristic to determine if you actually need a table. It's called the graph paper test.
Oh yeah, it's the perfect rule of thumb.
Yeah.
The test is exactly what it sounds like. If you have a set of raw information and your natural instinct would be to sketch it out on a piece of graph paper.
Like a university class schedule or something?
Exactly. A class schedule, a quarterly financial report,
Yeah.
the standings for a sports league. If it fits on graph paper, then that information structurally belongs in an HTML table.
Yeah.
It's explicitly for tabular data.
Right. Meaning data where the position in a specific row and column actually carries semantic meaning. The intersection of the X and Y axis is the data point.
Right, exactly.
But, looking back at the history of web design, there was this dark period where developers completely ignored the graph paper test. I remember viewing source code back in the early 2000s, and developers were using tables for literally everything on the screen.
Oh, it was a wild time. And understanding why that happened is actually a fascinating history lesson in browser architecture. Because today, you should never, ever use an HTML table for page layout.
Right.
But back in the browser wars era, I think late 90s, early 2000s, CSS was just incredibly inconsistent. Internet Explorer and Netscape Navigator rendered layout completely differently.
It was a nightmare.
Total nightmare. The only thing that was universally consistent across all browsers was the table element. So developers essentially hijacked the table structure to force their web pages into a rigid visual grid.
It's kind of like using a butter knife to turn a screw.
Right.
Like using a table for page layout is taking a tool designed for tabular data and hacking it to handle visual aesthetics. It might have worked in a pinch 20 years ago, but we have actual screwdrivers now.
Yeah, that's exactly it. And structurally, it was disastrous. To make a simple sidebar and a header, developers were nesting tables inside of tables. And they'd use these invisible single-pixel transparent images called spacer GIFs.
Oh, wow. Spacer GIFs. I forgot about those.
Yeah, just to force the columns to stay open. It created these massive document object models, the DOM trees that were totally bloated, impossible to maintain, and a nightmare for SEO.
Not to mention absolute torture for screen readers, which we'll get to in a second. Thankfully, CSS evolved. Layout is now the job of Flexbox and Grid, which were covered back in Chapter 3. So if we are building a true table for actual tabular data, what are the actual building blocks?
You're fundamentally working with 4 core tags. There's the table wrapper, which holds the whole thing, then the tree tag for the table row, the tag for the header cell, which is bold and centered by default, and finally the T tag for the standard data cell.
Okay, so that's the basic anatomy. But just having a massive wall of rows and standard cells isn't enough for the modern web, right? When tables get complex, we have to group that architecture.
Right. You use the head tag to wrap the header rows at the top. You use tbody for the core data rows, and tfoot for summary rows, like, say, the total line on a receipt.
And there's a functional browser benefit to that grouping, isn't there? Like if I print a massive financial report that spans 10 pages.
Yeah, the browser is smart enough to take whatever's inside that head tag and automatically repeat it at the top of every single printed page.
Oh, that's incredibly useful.
It is. But while those tags help with visual rendering and printing, there is a tiny, often ignored attribute that the deck highlights. And it is arguably the single most important detail for web accessibility. It's the scope attribute.
Okay, wait, let me push back on this for a second. If I wrap my column title in a header tag, a Luth tag, the browser already makes it visually bold. It sits perfectly at the top of the column. Doesn't the browser already know it's a header? Why do I need to explicitly add scope equals col or scope equals row?
That's actually the single most skipped accessibility detail in student code. You have to remember that visual rendering and the accessibility tree are two completely parallel structures in the browser.
Okay.
When you look at a screen, your brain instantly maps the spatial relationship. But a screen reader relies on an API that reads the DOMs sequentially. Imagine someone reading a massive spreadsheet to you over a phone call, just going left to right, top to bottom.
Just reading the raw data.
Right. Once you get 50 rows deep, the voice will just say a random number like 92. You have absolutely no context if that 92 is a test score, a user's weight, or dollar amount.
Ah, I see. Because visually obvious relationships are completely invisible to assistive technologies. It's just reading the text inside the cell. It doesn't look vertically up the column unless you specifically code it to.
Precisely. By explicitly coding scope equals cols on the header, you create a permanent programmatic association. Now, when the screen reader hits that cell 50 rows down, it can automatically announce score 92.
That is such a crucial shift in mindset. You aren't just coding for a screen, you are mapping relationships. Which brings us to the most delicate part of mapping relationships, merging cells. We have colspan stretching across columns and rowspan stretching down rows.
Yeah, it's really useful for group data, but it introduces a massive structural pitfall. A miscalculated colspan is one of the fastest ways to completely destroy a table's rendering.
It's exactly like playing a high-stakes game of Tetris. Think about it. Let's say your underlying grid architecture is 4 columns wide. If you drop a massive horizontal block into a row that takes up 2 columns using colspan equals 2,
You just consume 2 architectural slots.
right, you only have 2 standard slots left in that specific row. If you blindly try to cram 3 standard blocks into that remaining space, the math completely fails.
And when the math fails, the browser's layout engine just have to guess what you meant. It will usually take that extra data cell and violently push it right out the side of the table, shadowing your alignment. If your Tetris math is wrong, the browser won't save you.
Okay, so our structure is rock solid. Our relationships are mapped for accessibility, and our Tetris blocks fit perfectly. But let's be honest, default HTML tables are notoriously ugly. They look like a database dump from 1995. How do we make them actually pleasant for the user to read?
Well, the very first step is taming the borders. By default, every single cell gets its own independent border to simulate this like raised 3D effect.
Right, the doubled line effect, it's awful.
Yeah, it's highly distracting. We solve this with a single CSS rule on the table element, which is border collapse. It forces the browser to merge those adjacent borders into single clean lines.
Okay, here's where it gets really interesting, though. Reading wide rows of data across a screen is exhausting. Your eye literally loses its place as it travels horizontally across the white space. To fix this, developers use a technique called zebra striping.
Yeah, alternating row colors to make wide tables scannable.
But the best part is you don't need JavaScript for it. You don't manually add a class to every other row. You just use the CSS pseudo-class selector nth child. You literally just write tray colon nth child even in your style sheet.
It's so elegant. And because CSS is dynamic, if you delete a row from the middle of the table, the CSS engine instantly recalculates and updates the striping perfectly.
That's awesome.
But you always want to ensure the contrast of that stripe is extremely subtle. It is meant to be a guide, not a visual distraction. And then to take usability one step further, we add the hover state.
Right, tray hover. So the row highlights when the user's cursor is over it. It's a massive usability win for dense tables. It helps users track their place without losing their minds.
Definitely. And a quick tip here, pair that hover with a CSS transition. A smooth fade rather than an instant snap completely shifts the user's perception of your application from feeling cheap to feeling premium.
I love that. So tables are great for showing data, but communication on the web is a two-way street, right? How do we get data from the user? We have to transition to forms.
Yes, forms are when the website talks back. They're the engines of the interactive web.
And we use them every day. The slides list the big ones, like login with the username and password, contact forms, checkout pages for payment info, and search bars. But structurally, it all begins with the form wrapper tag, which requires 2 crucial attributes, the action and the method.
Right. The action is where the data is sent, the specific URL or server-side script. The method determines how that data is packaged and sent. The two primary methods are GE and POST.
Okay, let me make sure I have this analogy right for GET versus POST. Is GT like writing a message on the back of a postcard where anyone can read it because it just attaches to the URL in the address bar? While POST is like putting it in a sealed envelope, hiding the data inside the HTTP request for sensitive stuff like passwords?
That is exactly right. That postcard versus sealed envelope analogy is the perfect mental model. GET is great for a public search. POST is mandatory for anything secure. So assuming we have our POST envelope ready, we have to look at the internal architecture. Complex forms can cause massive cognitive overload.
Yeah, looking at a checkout screen with shipping, billing, and payment all at once is structurally chaotic. How do we organize it?
We compartmentalize using the field set element. A field set draws a visual and semantic box around a related group of inputs. And every field set must contain a legend tag, which gives that box a title.
So all the shipping inputs in one field set, payment in another, it maps perfectly to human mental models. But my absolute favorite usability detail in forms is the magic of the label element.
Oh, it really is magic. A label tells the user and the screen reader what a specific text box is asking for. But if you just place text next to an input, they aren't actually connected.
Right, you have to wire them together. You pair the label with an input using the for attribute and the id attribute. So you give the input an id, and the label e4 attribute that matches exactly. When you link them correctly, clicking the actual text of the label drops your cursor straight into the input box.
Yeah, and the reason this is so crucial comes down to usability on different devices. By linking the label, you effectively double or triple the size of the clickable hit area.
Which is a massive win. If I'm clicking with a mouse, it's a huge target. And if I'm tapping on a phone screen, it saves me from meticulously trying to hit a tiny pixel box. But what happens when we move beyond standard text boxes? What are users actually interacting with?
Well, HTML5 introduced a massive input buffet. We have type equals email, which natively validates the @ symbol. We have password, which automatically masks the characters. We have search, tell, date with native pickers, and number inputs with little stepper arrows.
But there is a crucial hidden benefit here for mobile UX, isn't there?
Yes, absolutely. Choosing the correct input type triggers the correct on-screen keyboard on a mobile device. If your code says type equals email, the mobile OS dynamically swaps the software keyboard to include the @ symbol. If it says tell, it completely hides the alphabet and just brings up the chunky numeric dial pad.
That is wild. It's not just about validation, it's about saving the user from hunting for the @ symbol. It respects their time. And beyond single lines, we have the Textareas tag for multi-line resizable text. We have select an option for drop-downs, checkboxes to pick any number of options, and radio buttons.
Right, radio buttons where you pick exactly one. And the mechanical trick to radio buttons is that you must give every button in that group the exact same name attribute. That shared name is how the browser knows they are mutually exclusive.
Ah, got it. So eventually, the user finishes interacting with all these inputs and needs to trigger the request. Which brings us to the 3 buttons.
Right. The submit button triggers the form action. The button type is used for custom JavaScript. And then there's the reset button. And I strongly warn against using the reset button.
Why? What's the danger?
It instantly clears every single field in the form back to blank. In 1995, over a dial-up modem, hitting refresh took forever, so a local reset button made sense if you messed up.
Oh, okay.
But today, it just sits dangerously close to the submit button. It is far too easy for a user on a touch screen to accidentally tap reset and instantly destroy all their hard work.
Yeah, just pretend the reset button doesn't exist. So the user fills out the form safely and they tap submit. But humans make mistakes. How do we ensure the data they typed is actually useful before we send it away?
We use validation. The absolute first line of defense is built directly into HTML5. It's free and requires 0 custom JavaScript. Adding the required attribute literally stops the submission if a field is empty. You can also use the pattern attribute for regular expressions, like formatting a course code or min and max for numbers.
And there's a brilliant lesson in empathy when it comes to styling these validation states with CSS. The browser automatically applies an invalid state to broken inputs. But the slides point out you need to use this sparingly.
Yes. Don't shame the user before they finish typing. If you aggressively style the invalid state to turn bright red instantly, the browser flashes red, the second they type the first letter of their email because it doesn't see an @ symbol yet.
It's just screaming error at them while they're actively typing. So if HTML5 validation is so great and handles the basics, why do we even need JavaScript validation?
Because HTML5 handles format, but JavaScript handles complex logic. HTML5 can't look at two separate inputs and compare them. So if you need to check if a password field and a confirmed password field match exactly, you need JavaScript. That's your second line of defense.
I always picture this JavaScript validation layer like a bouncer at a club. The browser tries to submit the form, which is like trying to just walk inside.
Yeah.
But JS steps in, uses an event listener, and e.prevent default.
Which completely stops the default action.
Right, stops the default action, checks the ID, meaning the data, and only opens the door if everything is valid. It's the exact same event listener pattern used for a mobile menu click from Chapter 5, just a different event and a new job.
That's a great way to think about it.
So what does this all mean? Like, where does the data go right now?
Right now, the action attribute points nowhere. The browser packages the data perfectly via method equals POST, but the actual receiving, processing, and saving of that data to a database will happen via PHP, which is coming up Chapter 7.
Ah, the handoff. And just to ground all this learning, the homework from the deck is a perfect exercise. Building a live site contact page, you build a table with spans and zebra striping for your availability, and below that, a form with labels, field sets, and validation. It ties everything together.
It really does. Because these simple tags, tables for structured data and forms for structured input, are the true unsung heroes of the interactive web.
Absolutely. You as the listener now know the difference between layout and tabular data and why that little for attribute on a label is a total game changer for usability.
And I want to leave you with a final thought on that. Something not explicitly in the textbook, but building directly on it. We spend so much time making forms frictionless and easy to fill out. But consider this, as you build forms that perfectly guide the user to hand over their personal data, at what point does reducing friction become a tool for harvesting information rather than just providing a good user experience?
Wow.
Yeah. Next time you seamlessly autofill a beautiful, perfectly validated form, ask yourself who really benefits most from that lack of friction.
Oh, man. That is a seriously provocative thought to chew on. The architecture is never truly neutral. Thank you for joining us on this deep dive. Keep questioning the digital world around you. We will see you next time.